Okay, I'm going to talk about partial fraction decomposition. All right, use this in calculus, okay? Because sometimes the form that you're given isn't useful and you need to split it into adding pieces, okay? If it was multiplying, it would not be bad, okay? So if this is factors, because remember, you multiply fractions straight across, right? So it wouldn't be too hard to be like, well, maybe that factor goes with this one and you just multiplied straight across, or maybe this one divided by that straight across. That would not be bad. Multiplying fractions, remember, is easy. You just multiply straight across, easy peasy, okay? Adding fractions is another thing because you need a common denominator. So even if you have like 1/4 and 2/3 and you're like, oh, well, yeah, multiplying them is way easier than adding because here you have to get a common denominator and then you have to do that math. And then after you do that math, you have to add it. It's not just like multiplication where you go straight across. It's not as easy. Okay. So I don't want to pull these apart as factors, as multiplication. I want to pull it apart as fractions, like x plus 4 over here, x minus 5. But then I'd have to like multiply both these by x minus 5 to get a common denominator, multiply these both by x plus 4 to get a common denominator. What would be in the numerator so that when it all adds together and factors, I get this. That's not as easy, okay? So pulling apart like 7/8 with adding, there's tons of ways that could happen. So a little tricky, but we can do it, all right? Now, what we do is we factor this to a base. So like 8 is 2 cubed, okay? So I know the denominator might be 2 cubed, 2 squared, or 2, and maybe if one of these is 0, like maybe that's not part of it, or that, and when we do the math, we can figure it out, okay? So this is how this works. Okay, so we're gonna do some algebra here. All right, so let's do this first one on top. All right, so what I'm gonna do is I'm gonna factor the denominator here. So the way you always factor a binomial is take a GCF out, greatest common factor, unless it's a perfect square minus perfect square, like x squared minus 16. That would be x minus 4, x plus 4. But this is just a greatest common factor. Okay, that's step 1. Step 2 is for every base factor, you make a fraction. So this is one factor, this is another factor. So you separate them out, okay? Your numerator depends on what you have. X is linear. What is a step down from linear? A constant, okay? Like if you're, 2x plus 3 is an equation, you go a step down, you just have a constant, like a number, like 8, okay? This is linear. A step down from linear is a constant. I'm going to use a different one. All right. Now, we have to solve for A and B. All right. So step number 1 is you're going to clear the fractions because remember with rational equations, we don't like fractions. So I am going to multiply everything, both sides, because you have an equation, you have a left side and a right. Everything is going to get multiplied by that common denominator. All right. So notice here the x cancels, x minus 1 cancels. I should get what? Negative 5x plus 4 on that side. Here, just the x cancels. I get a times x minus 1. Here, the x minus 1 cancels. I get bx. Okay. Now, I don't know how Newton or my math lab or whatever product you're using is going to use this. Some people multiply this out, bring the x's together, factor them, and say, oh, they should equal that. And again, still paint under my fingernail. And then the constant part should be 4. I don't like to do that. Okay, the way I like to solve these is pick friendly numbers to make life easy. So do you see how if x is 1, that is a friendly number because do you see how all of this will become 0? Because 0 times a would be 0. And then do you see how I can figure out what b is? That's how I like to do these. So again, it's all about input and output in pre-calc. So I'm going to sub in my 1. So I get negative 5 times 1 plus 4. Sub 1 in, all of that is 0. Plus b times 1 is b. Okay, I'll put the 1 there. But I'm just subbing in 1. All right. Over here, I get a negative 5 plus 4 equals b. Don't need to write the 1. Negative 5 plus 4 is what? Negative 1 is b. So I just figured out that this b is going to be a -1 when I rewrite the fraction. Okay, I know I canceled everything out, but we're going to write it as an addition fraction problem when I'm done. Okay, so now I have, oh, that helped me get this one. All right, now notice we have another friendly number. When x is 0 for input, do you see how the b goes away? Now, I do know what b equals, so I could put x equals 2, x equals 3, but you might as well pick the friendly ones. Okay, so I'm going to pick x is 0. I might have to move this guy down. All right, x is 0. That's my input. Okay, we're going to ignore this guy. So I'm going to sub that in down here. All right, so go to your original equation. Let me grab a highlighter. Oh, just lost my phone, but all right, here's my equation right there. That's what we're going to sub it into. All right, so I'm subbing in 0. So -5, I'll just show it, times 0 plus 4 equals, now a, I don't know, 0 minus 1, plus, now I know what b is, but this is 0 anyway, right? I mean, it's all 0. All right, so 0, that gives me a 0, plus 4. This is what? A times a -1. That's a -a, because you're multiplying there. A -1 times a is a -a, and then that's 0. All right, now if 4 is the opposite of a, right? We usually pronounce that the opposite of a. You can either divide both sides by a -1, or you could say a must be a -4, okay? All right, so we're just gonna, let's cross that guy off because I don't have space for him. All right, so now what we're gonna do is rewrite, we just figured out our numerator and our denominator. So when we had it as an addition problem, we had this, we split it into, we took the factor by itself and the other factor by itself. A, the one above the x, we got, what's a? -4, okay? And then the b, which is the one above this guy, the b is here, is a -1, okay? And if we were to get a common denominator, multiply it all out, do all our math, we would get this as an answer, okay? All right, so if you want to check your answer, probably the best thing you could do would be to graph this and see if they look the same. You know, if the function this plus this equals that on the graph, you should be good. All right, that's an easy one. We'll work our way up here. Okay, so let's try again. All right, I'm gonna pause and grab that other problem. Okay, before I do the next one, in general, I want you to understand this. It is all about the base. So do you see how the base here is x plus 5? You have to have 4 things for that because you don't know if it's x plus 5 to itself, x plus 5 quantity squared, x plus 5 cubed, or x plus 5 to the 4th, okay? Plus, I'm running out of space here, you have this guy too, x squared minus 1, you don't know if it's to the first power, or x squared minus 1 squared. So do you see how we have this factor to the 4th power? So I'm going to need that represented 4 times by itself, squared, cubed, and to the 4th power. This factor, this chunk, is exponent of 2, so I need it twice. Now, this is how you get what's on top. You only look at the base. The base of all of these is linear. Okay, the base, what's being to the power. So if the base is linear, a step down is a constant, a constant, a constant, a constant, a constant. Now, look at this one. Do you see how the base here is a square? It is a quadratic. So what's a step down from a quadratic? That would be a linear. So a step down from a quadratic second power would be to step down to the first power. That is going to be linear. So we have A, B, C, D. This is going to have to be EX plus F, because that's linear. A, B, C, D, E, F, G, H. So where's my X? Okay. So I have constant, 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 constant. Use those variables. Step down from quadratic is linear. So that would be like MX plus B, but we use E and F. And then again, don't look at this and say, oh, you know, no, only look at the base. It is quadratic. Step down would be linear. And what would be friendly numbers to sub in here? Well, let's see. I could sub in, oh, that's an x squared. Make that an x plus 1 because I don't want that factorable. There we go. Sorry about that. Do you guys see that if I left it, I could factor as x minus 1, x plus 1, you know, that would kind of change things. But this is not factorable. So I would sub in -5 after I clear the fractions. -5 would be pretty. Unfortunately, this is I and a -I. Those are not pretty. So I will show you another option when you run out of pretty options, but let's stick with the easy ones, but I want you to kind of get the idea, at least see what's ahead of us here. All right, let's do this one. All right, step number 1 is I'm going to factor. So x and x. Factors of 9 that give you 6 would be 3 and 3. Everything's positive, and you can see how your loopies would give you the 6x. So I'm good. All right. Now, you're going to want to rewrite this as a power so that you can see it, because that is really x plus 3 squared. Okay. So if this is squared and my base is x plus 3, I need x plus 3 by itself once. And then I need to build up that power. So it's only squared. So I have to have x plus 3 to the first power. We usually don't write the 1, right? X plus 3 squared. Oh my gosh, I can't talk today. All right, now look at the base. Look at the base, the factor. It is linear. A step down from linear is a constant. Okay, so we're going to call A. And again, don't look at the square there. Look at the base. The base is linear. Step down is a constant. Okay. All right. So now we're going to clear our fractions, because remember, when we solved rational equations, we do not like that. So I'm going to get rid of those. All right. All of this cancels. And again, this should be a pain, okay, because adding fractions isn't fun. One of these cancels. And then here, both of them cancel. All right. Okay, pick a friendly number, okay? So -3 is friendly for x because it would cause a 0. So I'm going to pick x equals -3. Sub it in. So -7 times, I'll just write it so that you can see it. Sorry. A, and this is going to be times 0. So that's going to go away, plus b. So this is going to spit out b. So what is this? 21 minus 15 is b. What is that? B is 6. All right, good. So I know what my b is. B is 6. Okay. Now the problem is I do not have any other friendly numbers. All right. So x is the only one that causes 0 there is that. So what you can do is pick any other number you want. Okay. So I'm going to pick 0 because I think x equals 0 is nice. It's not going to make anything equal 0 as far as canceling stuff, but it's going to be fine to work with. All right. This is going to be 0. So -15 equals, so it's not going to cancel one of my A's and B's is what I meant. Okay, it might, obviously this equals 0, but it's not going to make one of these disappear. All right, so that's going to be that equals A. If you sub in 0, that's going to be 3 plus, now the good news is you know that B is 6, so don't forget that. I'm going to stick that 6 in there because I know that. All right, solving the equations. Again, this is like 3 pairs of pants with a $6 meal. You can't add that. This is glued together. Okay, so I'm going to do the isolated inverse. So -6, what is that? Is that -21 equals 3a divided by 3. A is a -7. All right, so then what I'm going to do is go back and sub that in. So my original function, I'll just write it up here. So my a is what? -7. My b is 6. This denominator was just x plus 3. This denominator was x plus 3 quantity squared. These are equal, okay, for sure. All right, let me pause it. Let's look at another one. Okay, not pretty, but here we go. All right, so you look at the denominator. There's an x by itself. Now, if this was x to the 5th, I would need x squared, x cubed, x to the 4th, x to the 5th to build up. But this guy is just to the first power because it's a chunk as is. It's a factor. And this guy is just, again, to the first power. He is a chunk as is. Okay, and it's already factored for me. All right. Step down from linear is a constant. Step down from a quadratic is linear. So it's going to look like mx plus b. So bx plus c because I've used a here. This power, okay, again, we're not looking at the outside. We're looking at the base. Here it's a quadratic. A step down would be what? Dx plus e. Okay, next step would be we're going to clear all the fractions, and we don't really have a lot of pretty things to sub in here. So then this one, I'm going to show you how to sub in to create a system of equations, and then I'll show you Desmos, how to solve this on Desmos by doing linear, manipulation, reduced row echelon form as far as pivots on a matrice because it's going to be easier. All right. So I will finish this up in the next video.